In this video, we'll be covering power-reducing identities. Now, it's important to note that the power-reducing identities are these three identities right here. Sine squared of x equals to 1 minus cosine of 2x, all divided by 2, cosine squared x, and tangent squared x. The easiest way to remember these is you'll notice that the cosine squared x has a positive for its formula, while the sine squared x has a negative. But they're more or less the same formula. Then you have the tangent squared identity, which comes, again, from the concept of this sine squared divided by cosine squared to create tangent squared. So now how can we prove one of these identities? Well, it's actually quite simple. If we look back up at any of these identities up here, we'll actually start with this one right here. Notice how there's 1 minus 2 sine squared of x equals to cosine of 2x. If I were to rewrite that one down, cosine of 2x equals to 1 minus 2 sine squared x, and we were to solve this equation for sine squared x, we will then come to the conclusion of that power-reducing identity. So I'm going to go ahead and add the 2 sine squared to both sides, and I'll subtract the cosine 2x, giving me 2 sine squared x equals to 1 minus cosine of 2x. Now again, it's also important to note that this is sine squared of x, and this is 2x. These two functions can't be combined in any way, given the fact that, again, one's squared and one's a double angle. It's also important to note that they're sine and cosine, two different functions. But now here I can divide by 2. This provides me with sine squared of x equals to 1 minus cosine of 2x, all divided by 2. It's also important to notice that we can't divide this 2 into the cosine function, because there's no rules for manipulating the inside of a cosine function with the outside of a cosine function. So this is more or less how you prove those power-reducing identities, again, by utilizing your cosine double angle with either this identity or this identity to come to create this identity and this identity. In doing so, once you've identified those two, again, dividing them by each other can provide you with the power-reducing identity for tangent. Now, the last kind of question that you might be asked when dealing with power-reducing identities comes with the concept of writing the fourth power of sine of x such that it does not contain any power of trigonometric functions greater than 1. So again, the question is, write this into something else such that it doesn't have a power of any trig function greater than 1. So for us to do that, we're going to have to really recognize that, well, this is sine to the fourth power of x, and I can go ahead and rewrite that as sine squared x times sine squared x. It's the same thing. Again, you visualize this as technically sine times itself 4 times, so I can group it up as sine squared and sine squared. When I do that, I can then identify that using the power-reducing identity here, that sine squared of x is equal to 1 minus cosine 2x, all divided by 2, that each of those pieces is going to be that. So that means I'm going to have 1 minus cosine of 2x divided by 2, multiplied by 1 minus cosine of 2x divided by 2. Now there's more complicated versions of these problems, such that we might have a power of 6 here, you might have cosine squared times sine squared, you might have a power of 8 even here. The unfortunate circumstance is that we have to reduce the remaining functions down so that there are no powers greater than 1. So in this case, if I were to actually simplify this expression, I'll pull the divisions of 2 out, so giving me a 1/4 on the outside, and I'm going to have 1 minus cosine of 2x times 1 minus cosine of 2x. So I have to multiply these things out. Again, the expectation is that I'm going to have this most simplified version of this expression. So I have 1/4 times 1 distributed, then minus, it's going to be the cosine of 2x negative times 1, and a 1 times a negative cosine of 2x, so negative 2 cosine of 2x. And then finally, negative times negative is positive, cosine of 2x times cosine of 2x is cosine squared of 2x. Notice how I keep writing parentheses around the double angles, specifically to help reinforce where those particular details are. You'll also make note now that I have a cosine squared, which breaks the conclusion that we have to have a trig function that has a greater power, no greater power than 1. So I'll distribute this 1/4 to all the pieces, but before I do that, let's go ahead and take care of this. I have 1/4 1 minus 2 cosine of 2x plus I'm going to use the double angle identity for cosine squared of 2x, which converts that term only to 1 plus the cosine of 2x divided by 2, which means that I no longer have any terms that have a power greater than 1. I won't have any more multiplications, so there won't be any more powers greater than 1 if I were to simplify this down. So all I need to do is simplify this down term by term. I'll distribute the 1/4 through all the terms at this point to keep things completely simplified as possible. So I'll have 1/4 cosine of 2x divided by 2, plus I'm going to split this up into two separate terms, but each term is going to get a division by 2 and a division by 4. So that'll give me 1/2 times 1/4, which is 1/8, plus cosine of 2x divided by 8. The only thing I can do now is, if I wanted to, I could attempt to combine these two terms together, providing me with a 3/8, given that I can change this to be 2 over 8 plus 1 over 8 is 3 over 8. Lastly, the other thing I could do is I could multiply this one on top and bottom by 4, providing me with 4 over 8. And then I'll have negative 4 cosine of 2x over 8 plus cosine of 2x over 8, providing me with a minus 3 cosine of 2x all over 8. This will be, again, reducing this power of 4 function down into a simple double angle function. This is how you generally manipulate your power reducing identities, and the questions that we utilize power reducing identities with will most commonly be reduce this power so that the expression that you are left with no longer has a power greater than 1 on the functions.